Hey, it's your boy, Canfield. No, just kidding. Hi, everyone. It's Mr. Canfield. I said that because there are students in my room right now, and I thought that'd be awkward. Was that awkward? All right, so I'm just going to go through this packet for you. Okay, so it says above is a picture showing two similar triangles that are represented by the similarity statement. Okay, so they're similar triangles, which means the angles are all equal to each other. So like that and that are the same, that and that are the same, that and that are the same. And first it asks us to solve for angle C, which is this one here. Wait, I don't have that. Oh, but I know that C, so that and that are the same. My recommendation for doing this is, as I'm kind of explaining things, like pause the video, try the problem, get as far as you can. When you can't figure out what to do next, unpause, and then let's keep talking. Rewind if you need to. So those are equal, but I don't know what that is. I do know that all three angles in a triangle add up to 180 though. So I can say 60 plus 2x plus 25 plus 3x plus 20. I know that that has to equal 180 if I add it all up. So let's see, 2x and 3x, that's 5x, 60, 20, 85, 105. So when I added these up, I got 105. So I'll subtract, I get 5x plus 105 equals 180. So I'll subtract the 105 from both sides. I get 5x is equal to, is that 75? So then I get x is equal to 15. Let me just double check. I don't want to, let's see. 25 plus 60 plus 20, it is 105. All right, yeah, I did get 75 when I subtracted those. And 75 divided by 5, I get x is equal to 15. Okay, that's not our answer though. It wants to know what angle C is. Angle C is 2x plus 25. So now I can do 2 times x plus 25. And I get that C is equal to 55 degrees. All right. And that is the pace I'm going to try to do these. So just contact me if you have any issues. I would love to help. All right. If y represents the length of DE and z we want to find y and z in the diagram up top. So we want to find scale factor then, because similar triangles always follow a scale factor or a dilation factor. So 5 to 12.5, I could do, just divide them. So 5 times 2.5 gets me 12.5. So then I'll go to each of these. 5 times 2.5 gets me 12.5. So I'll just do each of these times 2.5. So 4 times 2.5 is equal to 10. And that would be y, because that's in the same spot as that one. So y equals 10. And then 8 times 2.5 is going to give us z. So 8 times 2.5 is equal to 20. So z is equal to 20. Okay. Nothing to it. All right, our next question. So I barely changed this question, but the procedure is going to be kind of different now that we have different numbers. So this is our triangle ABC, so 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. That's how we get the point 3, 5. Negative 1, 2, negative 1, up 2, negative 1, 2. So 3, negative 2, over 3, down 2. 3, negative 2. All right, so here is our triangle. And I am asked to find if it's an isosceles, an equilateral, or a scalene triangle. So what I need to do is find the length of each of the sides. So I can use the distance formula for that, which is going to be on the formula sheet. It says subtract the x's and square it, subtract the y's and square it, and then put all that inside a square root. So if I'm looking at this side here, at negative 1, 2, and 3, 5, well then the formula is going to be subtract the x's, negative 1 minus 3, square it, plus subtract the y's, 2 minus 5, square it. And then I can literally type that into my calculator. Yeah, don't show me that. So I just type it all in, bam, I get 5. So I'm going to repeat the process for the other two. So I'll do, let's see, 3, 5, and 3, negative 2. So 3 minus 3, we take the x's and subtract them, plus, take the y's and subtract them. That's 5 minus negative 2 squared. I'm just putting them into the formula. And then I'll go to my square root. Open it up, 3 minus 3 squared plus 5 minus negative 2 squared. And you might be like, Canfield, like, I can do some of this in my head. Sure, you're welcome to. I'm trying to give the, if you're stuck, this will work kind of way through these problems. So right now, those two sides are not equal. So it's not an equilateral triangle, because that means all 3 sides are equal. Let's do our third side. Let's see, negative 1, 2, and 3, negative 2. So that'll be negative 1 minus 3. We take the x's and subtract them, plus take the y's and subtract them. So 2 minus negative 2 squared. All right, let's see what we get. Square root. Negative 1 minus 3 squared plus 2 minus negative 2 squared. Oh, I get 5.7. 5.65. That 5 tells us to round the 6 up to a 7. Or you could say 5.66. There's lots of ways to round this. Hey, are these all equal? No. Are 2 of them equal? No. Since all 3 sides are different, this is called a scalene triangle. And then part C, is it a right triangle? Well, it kind of looks like I might have a right angle here. So the way that I check for a right angle is I calculate my slopes. And I can calculate slopes by counting rise over run. So 1, 2, 3, and then 1, 2, 3, 4. Wow, that's trash. All right, let's try this one. A little better, all right. So the slope for this one is 3 over 4. So in order for these to be perpendicular, I would need 3 over 4 and then 4 over 3, and one of them would need to be negative because you need reciprocals that are opposites. So that's what I need. Right now I have 3 over 4. Now let's see what the other one is. 1, 2, 3, 4. It's 4 down, and then it's 1, 2, 3, 4 over. Negative 4 over 4. Is that the flip of this? Is it negative 3 over? Nope, it's not a 3 and a 4 flipped, it's a 4 and a 4. So they are not perpendicular. Remember, a right angle has to appear for a right triangle to be a right triangle. Not perpendicular. Not 9 degrees. Not right triangle. Not funny. I don't know why I wrote that last one. Okay, onward and upward. In our next one, it says, well, we got our 2 parallel lines, just like in our review that we did before. So these 2 are parallel. There's our transversal, and it says, these are our 2 angles, and we want to find angle ABE. We want to find this one. So if I kind of label this one with a star, remember that this is also the star, and then this is also the star, and this is also this. Like all 4 of these angles are the same when we have 2 parallel lines cut by a transversal. And the same, like if I put a box here, this would be box, 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 box. That's a weird looking box. All 4 of those would be the same. So turns out these 2 are in the spot of being equal to each other. There's basically 2 ways I'd set this up. I'd either say 7x plus 4 plus 6x minus 5 equals 180, or I'd say 7x plus 4 equals 6x minus 5. They're either going to add up to 180 together, or they're going to equal each other. In this situation, since they're both in my star spot, they're both equal to each other. Had they been the way the original problem was, we would add them and set them equal to 180. So since we have this, a reminder for how we handle this. X is on both sides of our equals. So the first thing we do is we move the smaller x from one side to the other by doing the opposite of it. So it cancels, and we have a -5 left over here. And on this side, 7x minus 6x, we're left with 1x, or just a single, we don't even need to write the 1, we just write x. And the +4 comes down, so it says x plus 4 equals -5. So I'll subtract the 4, and I get x is equal to -9. Uh-oh. All right, this is what I get for making up the numbers on the fly. So when we want to find this angle, we do 7 times -9 plus 4. This is what angle ABE is. This is impossible. I made it an impossible question, but I'm getting a phone call. Hey, Mr. Brainerd. Good, how are you? Yeah. Sure thing? Mm-hmm. Cool. Well, I don't edit my videos right now, so that's in there. So we do this, let's see. Hopefully in a real test we would have a better question than this, because this right here, -59 degrees would be our answer. That's an impossible answer for like what we do, but we're just gonna, that's the math that we would do to get the answer, and hopefully the answer would make more sense. All right, we got a pre-image here. It says, determine the coordinates of the vertices if it's translated 3 units right and 5 units up. So 3 units right would be take each of the x coordinates and move them 3 to the right, which is +3. So 4 plus 3 is 7. 2 plus 3 is 5. And -1 plus 3 is 2. Okay. Then we have 5 units up. So that's each of these up 5. So we'll just add 5 to each of those. So 0 plus 5 is 5. 5 plus 5 is 10. And 3 plus 5 is 8. Okay. Thank you for sticking with me. All right, our next question. It's asking us for the surface area of this, and we're not painting the bottom of the house. So what I like to do is kind of look at all the pieces. So like I've got this wall here, and I know from my formula sheet I can look up the area of a rectangle, because this is a rectangle. And so 50 times 30 is how you find the area of that, base times height. Oh, sorry for the earthquake. I think that's going to be 1,500. All right, yeah. So that's this side right here. And if you see, I have this one and then the one over here. So I actually have 2 of those. So times 2, that's going to be 3,000. We would say cm squared. That's not, we haven't talked a lot about units. I'm not super concerned about that. Then I have this front piece, 10 times, the side is 30. So 10 times 30. So 300. And if you look, we have this front one and the back one. So there's 2 of those, totaling 600. So we got boom, 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 boom. We got all those. We got these 2 diagonal sides of the roof. They're 13 long here, and looks like 50 here. So 13 times 50. I got 650. And there's 2 of those. So 1,300. And then our last one is this triangle right here. And this is the tricky part. And so my advice to you is, if you get stuck on any part here, if you mess something up, just pretend like you got a number for it. So like I got that was, I don't know, 80, and then I'll double it because there's 2 of them. and then I'll add it together. And that's gonna, we're just gonna put a fake number there. We won't get the points for that, but we'll get the points for everything else. So it's a good test-taking strategy. So let me solve this out. So this is 13, this is also 13. The area of a triangle is 1/2 the base times its height. So we would need to know the height of this triangle. We know the base of it is 10, which means we can focus in on this half triangle right here. This is 13, that's cut in half, so that's 5. And now I can find that third side here. A squared plus b squared equals c squared. 5 squared plus b squared is equal to 13 squared. That's 25 plus b squared is equal to 169. When we subtract the 25 from both sides, we get b squared is equal to 144. So b is 12 when I take the square root of both sides. So 12, okay. So then I know the height of this piece here is 12. So the area of this triangle is going to be 1/2 times its base, which is 10, times its height, which is 12. I got 60. And there's 2 pieces of that. That's 120. So when we add these all up, that's going to be all the surface area, right? 3,000 plus 600 plus 1,300 plus 120. I got 5,020. It says a small can of paint covers 400 centimeters squared of surface. So how many bottles of how many cans of paint will we need? Well, if I know I have 50/20 of paint that I need, and I can divide that up into 400 cans, or 400 cm squared cans, I'm gonna need 12.5 cans. So again, if any part of this you blank on, you can, for A, like let's say you blank on how to find part of A, make up a number for the part you don't know how to do, because then in the end, you're gonna be taking that divided by how much paint you need. Like, that division is not that hard. So if I had an answer for A, then I could do B. And if your answer, it doesn't matter what your answer for A is. No matter how wrong your answer for A is, if I see that you divided by 400 for that part there, I know that you understand how to do part B, so I have to give you the points for part B. All right, 2 more. All right, this one, unfortunately, I didn't change a ton. It's not gonna be as helpful as I want it to be, because it's not gonna be a completely different kind of question, but I'm just gonna go through and kind of talk about how I would solve this. Or it's a proof, so how I would prove this. The picture below shows triangle ABC and CDE. Segment AB is parallel to segment DE. Oh, and they've got little markings on there. Point C is the midpoint. Point C is the midpoint of BD. Oh, so I can put markings in there because that's what midpoint means. Using either a formal proof or an informal but thorough explanation, verify the 2 triangles are congruent, that ABC and EDC are equal to each other. So first thing I know is that since I have parallel lines and this transversal cutting here, I know that that angle and that angle have to be equal to each other. That's called alternate interior angles. So I could say angle B is congruent to angle D because they're called alternate interior angles. So I know that's true. I also know that BC and DC are congruent to each other because midpoint cuts BD in half, in calf. I was thinking I should write midpoint C cuts BD in half. I also know that this angle here and this angle here are equal to each other. So I can say that angle, it's a BCA is congruent to, so I started on that guy, so I'll have to start here, DCE. And that's called vertical angles. So since all those things are true, I now have angle that matches, side that matches, angle that matches. That's ASA. Actually, I can say, therefore, triangle ABC is congruent to triangle EDC by ASA congruency. So this is a informal proof of it. Don't worry about formal proof. But I showed, oh, they're congruent by ASA. And how do I know that they're congruent? Well, I know those two are equal, I know those two are equal, and I know those two are equal. I just say how I know that they're equal. Final round. All right, so we got a dude, we got a flagpole, and he's 500 feet away, totally different. This is a 10-degree angle here, this is a 30-degree angle here. So this really is just two different triangles. So we got a 30 with 500, and we got a 10 with 500. And we want to know this piece right here. Well, if we can find the whole distance there and then the building, we can subtract them and we'll be left with what the flag is. So if I do this one, I'll call that one X, I'll do this one, I'll call this one Y. We can say it's a right angle. Wait a minute, that's my opposite side. This down here is my adjacent side. Hey, that's tangent. So I'm gonna say tangent of 30 is equal to X over 500. And I just cross multiply and solve it, right? 500 tangent 30 is equal to X. I'm gonna make sure I am in degree mode. If you're using one of my calculators, I would say it probably is in degree mode. Tangent 30, you get 288.68. And then on this one, I can say it's gonna be the same setup, just different numbers. Tangent of 10 degrees is equal to Y over 500. We'll cross multiply 500 times the tangent of 10, and I get that Y is equal to 88.16. Okay. Well, I know the flagpole is going to be the difference of those two. So I'll take 288.68 minus 88.16, and I just chose to round to the second decimal place. The flagpole is 200 feet tall. I was like, this one's going to be silly. All right, so all right, well, I hope this was helpful. You know where to find me if you have any questions. All right, bye.